All right, so we're going over the Unit 3 review here on functions. First up, we got the height of these hedges as a function of time. Before I read through all the answers here, we're starting off pretty slow here, so time is always increasing. The height isn't going up too much; it goes up real quick. Probably got cut here. So hedges grew slowly at first, but then grew faster with fertilizer before someone trimmed them. So answer is B for number 1 there. Moving on then. All right, so we had an absolute value function graphed here. We're just trying to get the value of the function at -4. So -4 is right there. Looks like we're at 2. F of 3, so we get 1, 2, 3, go down, we're at -5. F of 13, so 13 is right there. We go up, we're at 3 again. So when f of x is 5, so that's up here, so actually have 2 values. So when f of x is 5, so you're checking out the y first, and then you're going down to the x. It would be x equals 15, and over here would be -7. So x equals 15 and x equals -7 when f of x is 5 there. Next up, domain and range. So domain right here, your x's, we're going from -1 to 4. My range, my y's, I'm going from -3 up to 2. Notice this is just a line segment, so that's why we're limiting it just between these numbers. It's not going any further than that. All right, so remember, in order to have a function, our x values can't repeat. So what set of ordered pairs could be added to the relation so it remains a function? We just can't have -5, -4, -3, or -2 here. So in this one, -5 would mess it up. So that doesn't work. Here, you'd have the... Actually, that's okay. -6, -1. Those are both good. Because this one would be bad because you got the -2. This one you got the -3. So your answer would be B for that. So we're at a function rule. Airport parking is available for $8 per day. So you could say f of x equals 8x. For this one, a glass of iced tea costs $2. Refills cost 25 cents each. So f of x equals 0.25x plus 2. Independent versus dependent variable here. The independent would be how many photos you get. Your dependent would be the total cost then. Again, you have control over how many photos you buy, like if you do print your photos at CVS or something. You have control over how many photos you purchase, and then how the cost is going to depend on how many got printed. All right, so next up we're evaluating these functions. So first up I got f of -5. So it's going to be -5 squared plus 5 times -5 minus 7. So it's going to be 25, positive 25 since it's -5 squared. -5 times -5 is positive 25, and then we'll have a minus 25 minus 7. So 25 minus 25 is 0, minus 7, -7. G of 4, so it's going to be -3 times 4. Plus 5, so it's going to be -12 plus 5 is -7. So g of f of 3, this is where you had to figure out one function, then the next. So we're just going to leave g alone. We're going to figure out f of 3 first. So it's going to be 3 squared plus 5 times 3 minus 7. So 9 plus 15 minus 7. Just trying to save some space here. So that's going to end up with g of 9 and 15 is 24. 24 minus 7 is 17. So now I got to figure out g of 17. So that'll be negative 3 times 17 plus 5. So that's going to be negative 51 plus 5 is negative 46. Next up, we got g of negative 2. So g of negative 2 is negative 3 times negative 2 plus 5. So that's going to be g of 6 plus 5. So g of 11. So that's my new job here. So g of 11 is going to be negative 3 times 11 plus 5. So negative 33 plus 5 is negative 28. All right, moving down, then we got to do a graph. Any linear function, your domain is going to be, I know I said, graph it for this, but remember, domain with linear functions is always going to be all real numbers. You can substitute any number you want in. Range is also all real numbers. These lines go on forever. We're just graphing a couple points to see where it's going. So negative 3 times negative 2, I'm just going to write out one of these, and we'll get 6 plus 5 is 11. Negative 1 will be 8, 1 will be 2, 2 will be negative 1. All right, so there's our line. Again, domain range, all real numbers. These are just a couple points we graph to get the shape of, see where the line is. All right, so next up we have a quadratic function. All right, so there's our graph. Domain, again, our domain's going to be the same for all these all real numbers. And my range, my y values are all greater than or equal to 0. The smallest y value I have, I come down, get to 0, go back up. All right, so we have f of x equals the absolute value of x minus 4 minus 3. So let's go over like one of these. You have 0 minus 4. So you're going to get the absolute value of negative 4 minus 3. 4 minus 3 is 1. So absolute value graphs, we get the V-shaped graph. Again, domain, these are just x values that I gave you, but really your domain, you could have picked anything you want. But we want to get the shape of the graph there. Your range, again, is y is greater than or equal to. Your smallest y value there is -3. So all the y's are greater than or equal to -3. All right, so identify the mapping diagram that represents the relation and determine whether the relation is a function. All right, so this one, we got -8, 6, -5, 2, -8, 1, and 7, 3. So I know with these -8's repeating, it's definitely not a function. So it's got to be C or D. And we had -8, -6, -8, and 1, -5, 2, 7, 3. So D. So next up, Crystal earns $5.50 per hour mowing lawns. Write a rule, describe the amount of money earned as a function of the number of hours. So her function is going to be 5.50h. How much does Crystal earn if she works 3 hours and 45 minutes? So you do 5.5 times 3.75. 45 minutes is 3/4 of an hour. So it's going to be 5.5 times 3.75. $20.63. So D. Next up, a snail travels at a rate of 2.35 feet per minute. Write a rule to describe the function. How far will the snail travel in 5 minutes? So we need 2.3 times t. And after 5 minutes, if we do 2.35 times 5, we get 1.75. So D again. All right, so when doing problems like this, you're trying to determine which is the graph of x squared plus 1. If you let x, make an xy table. If I let x equal 0, I'm going to get 1. So I need to pick a graph with 0, 1 as a coordinate. So that's definitely not A, and it's definitely not D. It's got to be B or C. So then take another point. Let's say if I put 1 in, and x is 1, I should get 1 plus 1 is 2. So which one has 1? 2 is a point. That's going to be C. So again, you don't have to exactly know the shape of the graph that you're going to get, but just start plugging points in that are on this graph and see what happens. Same thing down here. If I put 0 into this, 3 times 0 minus 1 is 0 minus 1 is -1. So I should have 0, -1 as a point. So that eliminates that and that. So now it's A or D. Like I said, I would put in 1. So 3 times 1 minus 1. So you're going to get 3 minus 1 is 2. So where do we have 1 comma 2? D. All right, so a taxi company, maybe bring us up to current times, maybe an Uber, charges passengers $1 for a ride and an additional 30 cents for each mile. The function rule C equals 0.30 m plus 1. Describes the relationship between the number of miles m and the total cost of the ride. If the taxi company will only go a maximum of 40 miles, what's a reasonable graph for the function rule? So I'm going to eliminate C and B right away because we're going beyond those 40 miles there. Okay, and this one, this graph down here for D eliminates 0 through 10 miles, which is weird. A lot of times your taxi ride's only like a mile or two, I bet. So your answer is definitely A. The miles driven could be between 0 and 40. You traveled 10 miles. Those points are going to be the same. But again, this one's kind of cutting out that first part there. I mean, you could go 5 miles. There's nothing against that. Okay? So that's it.